So continuing our scientific notation. The rule is we always have to have only one thing in front of the decimal, and then we can have as many things after the decimal as we want, all raised to some power. You can also use this to deal with very small numbers. So you know that 10 to the negative 1 is 1 divided by 10. And 10 to the negative 2 is 1 divided by 10 times 10. You knew that, right? So a tenth and a hundredth. When you have a very small number, we use negative exponents. Let me get rid of that. Well, that didn't work. When we have very small numbers, we use negative exponents. So if we have 0.0032, that is actually 3.2 times 10 to the negative 123. And a word about putting numbers in and out of scientific notation. I think I've mentioned already once today, and it'll probably come up again. I love math. I love numbers. I've always been really comfortable with math. I feel like a clunky, clumsy, grubby 5th grader. I still make bumps under my numbers. You can make bumps under your numbers too. It's okay. As a matter of fact, we're going to talk about something that over, 8 years of teaching chemistry, I've seen as the most common mistake, and it's a mistake that I still make if I don't use the system that I built for myself to prevent making that mistake, and I am going to clue you in that it involves bumps under and over numbers. So we're going to talk about that. Let's do just a couple quick practice ones. You can add these to your notes. So 7,260 somethings in scientific notation. Go. And if you have the 0 there or not, it's fine. Next week we'll know why you shouldn't. Now, try 87 million. Gene chemistry, people come in, they know how to do this. This is not the hard part, okay? But I just want to address it. So, 8.7 times 10 to the 6th, right? 1, 2, 3, 4, 5, 6, 7 times 10 to the 7th. Okay, 8.7 times 10 to the 7th. Yeah, good? Okay, I'm going to give you some practice on it. Now let's do some smaller numbers. 0.00726. Go. 7.26 times 10 to the 1, 2, 3. Negative. And 10 to the negative 3rd. Good. Easy. Easy peasy. Oh. Negative 10th. Yes? All right. And generally these are things that everybody's pretty comfortable with. Here's where it gets a little weirder. So operations with numbers that are in scientific notation. There are two different sets of rules. One set of rules for addition and subtraction. And it looks like two, but it's really one rule for multiplication and division. We don't do a whole lot of addition and subtraction. We do some. You should be familiar with it. We do a ton of multiplication and division. So we're going to sort of glance at the addition and subtraction, and then we'll really work on the multiplication and division. And then I have a practice sheet for you because we'll have a FIP on Monday. With numbers that are this small, we've got one that's in the hundreds and one that's in the thousands. It would be easy enough to just fluff, I always say fluff them out. It's not very technical terminology, I realize. But sort of inflate them to their full values. So yeah, 3, 2, 0, 0, 1, 2, 3. Okay, so I'm looking at 3,200, and here I'm looking at, let's see, 27000. Yeah, let's see, 1, 2. Okay, I'm looking at 270, and add them. That would be easy. But when we're dealing with things that are to the negative 23rd or to the 26th, 10 to the 26th, 10 to the 23rd, 10 to the negative 31st, we can't do that. So we have to be clear on the rules for doing this process with numbers that we can't sort of cheat with. So I want you to know that you could do this with smaller numbers, but I want you to not be in the habit of doing that. So what we have to do is move the decimal places. And this is the number one area where students screw up. It's the number one area where I screw up if I'm not really careful. So because I've made all the dumb mistakes, I have developed a carefully orchestrated series of steps to avoid making them again. And then we can just add the numbers. that means we're going to have to move these around, and for a minute they're not going to be in proper scientific notation. So I'm going to go with the larger of the two exponents, the greater magnitude. So I'm going to keep 3.2 times 10 to the third as it is. And this one I'm going to get into 10 to the third notation. I will make a confession. I can't reliably tell left from right. It's never been obvious to me. I don't know why. It's miswiring in my brain. I've met a few other people in my lifetime who are in my club. I have to do this. I have to write L's and R's on things, whatever. So I do not use the language of moving the decimal right and left because I screw it up and then I confuse students. So I don't want to do that to you because I used to try to do it and I would try to get it right. Ask Mrs. Berger sometime how good my left and right is, because one night I gave her directions to go someplace and all the turns were wrong, or at least enough of them that she was about an hour late. So I don't try to use left and right because I think I'll screw it up. So I will draw arrows in terms of which way we're moving the decimal, and I talk about in front of the decimal, which is stuff out here, and behind the decimal, which is stuff back here. So if you can all deal with my terminology, if you get left and right, if it's obvious to you and you want to say left and right, go ahead, but I'm not playing that game because I can't. So we want this to be times 10 to the third. Well, I do this for myself. And this is, I'm going to color code this. This is where my decimal is starting. I put it in a different color. And this is currently times 10 to the second. So it's easy with a small number, but it's harder with the giant numbers. So develop the methodology here. I go, okay, let's see, 1, 2, 1, 2, 3. This is where my decimal will end up. So I literally do little bumps for myself on the bottom, going one direction to sort of start to fluff it out, and then back the other direction to replace that decimal in 10 to the third. Now, for me, and probably for you too, once I get warmed up and I've been doing these for a little bit, I don't have to go all the way. I just have to like mentally go, okay, well this would be 1, 2. Okay, I go back more this way. So it's just a little sort of visual mnemonic for myself. You can use it, you can ignore it, whatever. So this becomes 0.270 times 10 to the third. So now I just have to add 3.2 and 0.70. So what do I get? 3.470 times 10 to the third. Okay? So the key is that you are making those exponents match, and then you are adding the fronts. And really what you're doing is just shifting the decimal around. You're aligning the decimals. We don't do as much of this, but that's what it looks like. The one that we do a lot of is multiplication and division, so let's practice that. Exponents, because all you have to do is say 2.6 times 4.2, and then the whole mess is times 10 to the 2 plus 7. So you multiply those first parts together, and then you just add the exponents. Easy peasy. Makes life very simple. Yeah, there's a problem. Crap, it's the problem I hate. I have to move the decimal because that's not in correct scientific notation. It's going to have to be 1.092 times 10 to the something. I do this. 10, 9, 2, and I put all my zeros here. I'm not going to go all the way to 9 because that's ridiculous. But I'm going to warm my brain up and think, okay, 1, 2, 3, 4. Okay, if I'm coming back further this way, the exponent is going to be larger. So this is going to be 1.092 times 10 to the 2. And if you need to draw your bumps all the way out, give yourself a whole bunch of zero space, and you can sure do that. And I'll demo what that looks like. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? If you want to do bumps forward and backwards, you can. I will not think less of you. I will think, well, there's somebody who knows where they're going to make a mistake, and they're preventing themselves from making that mistake. Okay, let's do a division, and then I'm going to turn you loose to practice. So if, and then we'll do a combined problem. All right. 7.41 times 10 to the 7th divided by 2.9 times 10 to the 3rd. We do a lot of these. So all we have to do is break out that front part, 7.41 divided by 2.9, and then the whole mess is times 10 to the 7 minus 3. Times 10 to the 4th? That's the raw number I get. It's always good to show your raw number. In fact, I would only keep this as 2.6 times 10 to the 4th, but you don't know why yet. We haven't talked about sig figs yet. Okay. I went and left my 10 to the 4th. Good? Okay, let's do one that's a combined problem, and then I'll give you the practice and cut you loose. So if I have 8.6 times 10 to the 23rd, times 2.4 times 10 to the negative 3rd, divided by 4.8 times 10 to the 17th. How do I handle this? Same way I've handled the rest of them. I'm going to separate out the front parts of all these numbers. I'm sure there's a mathematical term for that, and I don't know what it is, which is going to bother me all day. I'm probably going to have to go visit Mr. Andres. He's my go-to guy for math terminology questions. So I'm going to do my multiplication, I'm going to do my division, and then the whole bloody mess is times 10 to the 23 plus negative 3 minus 17. And yes, I literally will put in plus negative. I don't change signs on these. Reason being, as we get into more complicated ones, and you're subtracting negatives and everything else, for me, I can track my own mistake path better if I haven't changed the signs, if I showed that I was adding a negative or subtracting a positive. Okay. Yes? Okay. There's practice. There is a practice sheet on the corner of lab table 1. I will give you some points for completing the practice. Those will be due on Monday. And then on Monday, when you walk in, now what I've typically done is I've combined the first FIP quiz, and it's been scientific notation and measurements. Maybe we'll do that again. Let me think. No, you know what? I'm probably going to do a FIP quiz for you guys on just scientific notation because I want to make sure. So no pitfalls. Have I explained to you what a FIP quiz is yet? Okay. FIP, formative instructional practice. I told you about them. You get a point. Okay, good. So we'll do that on Monday. Practice is on the corner. You are cut loose to work. I'm going to circulate and see who needs help and who has questions and who's just rocking it.